We've reached the end of Moore's law. There's no way to double the number of transistors on an integrated circuit without erecting huge data centers that consume way too much energy. I spoke with NTT Research CEO Kazu Gomi all about what comes next.
The truth of the matter is that we are reaching the limit. Law of physics is telling you that you cannot go any thinner of all those circuits on the chip. That's where we are. We are in the inflection points. The true problem on the Moore's law is that we cannot stop the great technology advancement through AI, through big data. Having more servers and routers and all that means more energy consumptions, basically heating the earth more. Mm-hmm. Mm-hmm. So we have to address this somehow. One of the base concept is that how to support the technology advancement through the capacity increase and bandwidth increase, but how do we control the energy consumptions? So achieving those 2 or 3 things all together, and we believe optical technology is the key to address this challenge. When it comes to the wireless, we also want to talk about more wide range of coverage and again more bandwidth. But optical can pitch into that area, but the wireless, its own technology, we have a couple of different interesting ideas to make that wireless technology to the next level as well.
What we're talking about is making it possible to vastly expand the distribution of data capture, sensors, devices, but not just like the devices we have now that capture data and dump them into the data lakes, but very smart sensors.
Core of the I1 is certainly in this optical devices, and then by having the optical devices and more bandwidth in the networks and the more computation powers that we need, and the optical technology can address that problem as well, we believe. I think when it comes to the sensor, there are so many different kinds of sensors already being implemented, and then I think each type of sensors, everyone is pitching in to make that sensor more, in a way, intelligent and more precise. Basically, more sensors are out there, meaning more data to be created, and how to handle already pretty large amount of data we are creating and analyzing it, but that volume of the data is continuing to increase. I1's contribution to this world is how to move the data, this vast amount of data from point A to point B, and also how to analyze the data quicker and a more efficient way. And another thing, how to maintain the security of the data that the sensors are all collecting, how to maintain the privacies and the sensitive data that all kinds of sensors are collecting, and how to manage that. We have a better way to do that to make this business sustainable.
You have some scientists working specifically on anticipating and solving the optical technology challenges that have to be solved.
So at the end of the day, optical circuits become very interesting once you put light into it, right? And so how do you produce the light? And then that's basically the laser oscillators. And there we want to make those laser oscillators as small as possible so that we can integrate more into a chip. That's one direction. And also that this laser oscillator can create the very short pulse. And the shorter pulse, basically you can just do more things within a short period of time. So
it exponentially increases the bandwidth.
It's that's the source of the increase of basically the bandwidth. So the short pulse is very important, and then again, to make that the optical circuits working, you need a laser light, and how to make those laser light source smaller, so we can just get more integration possibilities.
And this is on top of the power consumption savings that is at the bottom of all this anyway.
So because of those devices become possible, we can do more on the optical domain rather than the electron domain, and then we should be able to save some energies. With regard to that saving energy, from the basic research point of view, a lot of interesting projects going on, and I'm pretty excited about is the following. Especially for the data processing part, where that energy consumption is really got to the concerning point, is that the driver of that is AI. AI, needless to say, it's very exciting. A lot of good stuff going on. Deep neural network, large language model. No matter what, I think that basically AI engine is becoming very, very big. So basically, entire data center is basically physically consumed by the AI engines. So
it's a bottleneck that optical sensors will.
And then or more of the biggest problem is that it's huge energy draw to run the AI cluster. Optical circuits can address this issue by using fiber optics in a very smart way. We can potentially replace those GPU with the optical circuits, and then by doing that, we can do the same computations that the GPU is currently doing with this optical circuits. And the big benefit of that is it is as fast or faster than the GPU. And then biggest, I think, a benefit for this approach is that the energy consumption is so much lower than the GPU.
If we can do that, make this great leap forward in AI, enabling it to run more efficiently, what that great leap forward will enable in terms of like truly smart cities.
Yes.
Vastly autonomous transportation.
Right, yeah.
Medical breakthroughs, which is an area you guys are in as well. But
I talked about that, so AI engine can be run and then without much of the energy footprint. If you can do that, assume all the current AI engines are sitting in the large cloud data centers because of that the energy requirement is so big. So you cannot take it everywhere. It has to be very well designed data centers has to be there. But if energy requirement is so much smaller, you can put the same or very similar computation power to the edge, or ideally to the drone flying on the air or in the car that running on the street. You can embed such intelligence into those cars or drones or any of those edge devices.
Yeah, it's you're moving some of the computation out to the edge.
From there, I think you can imagine many benefit of it. So much quicker response to whatever intelligent analytics needs to be done on the edge. So right there, much quicker. That's effectively very interesting world that we should be able to create.
The mission statement is pretty explicit about trying to achieve this new optical-based wireless supporting infrastructure, specifically to foster a rich society that's tolerant of diversity, respectful of individual privacy. What's the business case for that? There's got to be a business case for that, right?
Yeah, if we don't address this game-changing technology from silicon-based conductor to optical-based, electron to optical, if we don't do something drastic like that, carbon footprint issue will become so large that we have to start thinking about toning down the size of the AI engines and so on. Or by applying the optical, like I mentioned, that we should be able to move the AI computations to the edge and so on. So by doing so, we should be able to get more smart societies. At the end of the day, I think probably the size of those industries related to those benefit from those smart infrastructure will become much bigger. So if you ask me about the business case, I think a whole industry pie will grow on this regard. And then always that people kind of are afraid of when AI will replace all the human beings or something like that. There's also certainly a little bit different social aspect to that concerns. ion itself may not address that issue. I think there are certainly some other areas of consideration needs to be taken into what's the right balance between humans and AIs, and what's the ethics of AIs and all that. That needs to be addressed from different angles.
Well, that's a lot to think about. That's fascinating.
It's a kind of like our passion, so to speak, in to talk about the technology and what to think about the impact of the technology for the future. So yeah, this is a very good conversation. Thank you.
Thank you very much, Gomi-san, for your
Thank
time.
you.